So in this example, we're going to use polynomial identities to do some multiplying. So yes, you could just take 2x squared plus y cubed, write it again, and FOIL it, right? And that would get you the right answer. But also use an identity to get it faster. So this would be the sum of two, well, this is a squared binomial, right? So now we're using the square of a sum identity in order to solve. The square of a sum is equal to a squared plus 2ab plus b squared. So in this example, a is going to be 2x squared and b is going to be y cubed. So you simply substitute 2x squared in for a in the identity, and you substitute y cubed in for b in the identity, and you simplify that. There's a lot less work if you just use the identity, and what you're going to end up with is the same thing you would have ended up with if you did what at the beginning what I described as just foiling the two binomials together. That would have been a lot more work. Still got the same answer, but this is more efficient. Another use, 41 times 39, obviously just type with the calculator. So I get that, but in order to do this by hand, you could use an identity. Both numbers are pretty close to 40, right? So specifically, they're both 1 away from 40. So 41 can be written as 40 plus 1, 39 can be written as 40 minus 1, and what they become is a difference of squares identity. So what it ends up being is 40 squared minus 1 squared, which ends up being 1,599. Okay. Now we've got two that we're going to try together. Well, I'm going to pause it, you try them, and then come back and check it out. For part A, that's a difference of squares identity. So it would just end up being a squared minus b squared, where a is 3x squared and b is 5y cubed. So you set it up that way and then simplify, and you get 9x to the fourth minus 25y to the sixth. Part B is a square of sums. So that ends up being a squared plus 2ab plus b squared, where a is 12 and b is 15. Simplify that and you end up with 729. All right. Let's check out example 3.